Alright, today we're going to talk about what's called a piecewise function. A piecewise function is a function whose formula changes depending on which input values are used. So if you'll notice here, we have 3 different functions with 3 different input values. So we're going to go work a problem where we have 3 different functions and 3 different input values. So I'm going to have 3 different t-charts. I'm going to have a t-chart for y equals x plus 3. I'm going to have a t-chart for y equals 5. And I'm going to have a t-chart for y equals the square root of x. Okay, for each one of these t-charts, they even tell me which x's I'm going to use. They tell me on this one, I'm going to use the x's between -3 and -1. But you'll notice this one has an equal to, and this endpoint does not, which means it's going to be an open circle on my graph. So I'll circle it in here so I don't forget. On the next one, it tells me my x's are going to go from -1 to +1, -1, 0, 1. Both my endpoints are going to have closed circles. On the last one, I'm going to go from 1 to 9. So 1, I'm not going to do every single number. I'm just going to do my perfect squares because I'm taking the square root. And 9. And notice that both of the endpoints have open circles. Okay, so now what I'm going to do is take my x's and I'm going to plug them in. So -3 plus 3 is 0. -2 plus 3 is 1. And -1 plus 3 is 2. So I can already start graphing. So I know I'm going to have a point at -3, 0. I'm going to have another point at -2, 1. And I'm going to have a third point at -1, 2. But this one's going to be an open circle. And I'm going to go connect those 3. Okay, second part. So y equals 5 when x is -1, 0, and 5. There's no x to plug in. It is simply 5 all 3 times. So now I'm going to go graph those 3 points. So I'm going to have a point at -1, 5, 1, 2, 3, 4, 5. It's closed. I'm going to have a point at 0, 5. It's closed. And I'm going to have a point at 1, 5. And I'm going to connect them. Okay. My last graph over here, the square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. Remember, these endpoints are both open. So I'm going to go graph 1, 1, open. I'm going to go graph 4, 2. Now 4, 2 is not an endpoint, so that one's going to be closed. And I'm going to go graph 9, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. And here's 3. So that's going to look like this. Okay, so this is called a piecewise graph. Now that I have my graph, I can go answer the questions. They want me to find the domain. Okay, so I have to look carefully. I can tell that I'm using the point -3. And at first I think because there's a hole here, I'm not using 1, but I'm using the -1 up here. So I'm actually using everything from -3 all the way over here to 9, but 9 is not included, so I put a parenthesis. B asks me to locate any intercept, so anywhere it touches the x or anywhere it touches the y. It touches the x right here at -3, 0. It touches the y at 0, 5, and that's it. C wanted me to graph it, so I can label that C. And D wants me to find the range of the graph. Okay, so the range is going to go from the lowest point to the highest point. Okay, so it looks like I'm using this right here. It almost looks like there's a hole at the 1, but I used it here. And I used that. So it looks like my y values went from 0 all the way to 3. And then again, I have a 5. Union 5. There's our piecewise graph. Okay, so we're going to do one more of these together, and this one's actually on your homework paper. It's the same type of problem. We're going to set up 3 t-charts and then answer the questions. Okay, so t-chart for x squared, a t-chart for y equals 2, and a t-chart for y equals 2x plus 1. Okay, so for my x squared, it wants me to pick numbers less than 0. So I start with 0. Less than 0 would be 1, negative 2. There's no equal to, so this is where my whole will be. Okay, 0 squared is 0, negative 1 squared is 1, negative 2 squared is 4. Next graph. They want me to only use 0. So when x is 0, y is 2. Okay, and it's equal to, so that's going to be a solid point. The third one, they want me to use numbers bigger than 0. So 0, 1, 2. The 0 again is not included, so there will be a whole. So 2 times 0 is 0 plus 1. 2 times 1 is 2 plus 1 is 3. 2 times 2 is 4 plus 1 is 5. Okay, so now I can go graph it, and then I can answer all the little questions that they want. Okay, so I'm going to have a whole at 0, 0. I'm going to have a point at negative 1, 1. And I'm going to have another point at negative 2, 4. 1, 2, 3, 4. So this left side of the graph is going to look like a half a parabola. And it says it goes on forever, so I drew an arrow. The next one says I need a point at 0, 2. Closed circle at 0, 2. Then I need an open circle at 0, 1. I need a point at 1, 3. So 1, 1, 2, 3. And I need another point at 2, 5. So 1, 2, 3, 4, 5. And this is a linear function, so it'll look like this. And I draw an arrow. This one looks really weird. Okay, so we're going to answer all the little questions. They want to know what is the value of the function when x is negative 2. So when x was negative 2, it equaled 4. They want to know what is the value of the function when x equals 0. X has a closed circle at 0 at the 2. What is the value of the function when x equals 2? When x equals 2, the value is 5. Okay? They also want me to find the domain, locate any intercepts, and find the range. Okay, so the domain. It looks like I'm going forever to the left. I actually do include the 0 and forever to the right. So my domain is going to go from negative infinity to positive infinity. B wants the intercepts. The only place I actually touch an x or a y is right over here on the y-axis at 0, 2. C wanted me to graph it, so here's C. D wants to know the range. Well, it looks like I'm going to be everything bigger than 0, but not including, oh no, I do include 0 right there. So everything bigger than 0. So but my y value is not 0, so it's going to be open parentheses, 0, comma, to infinity. Okay, so now you have enough information to work on the rest of worksheet 2.5. You got part of it yesterday with the graphs of the parent functions, and now you should be able to finish all of 2.5.